Welcome to On Chemistry. Always try to do your best. Now, let us see about 100 conversion in organic chemistry. We are seeing it as episodes. This is the episode number 101. If you didn't watch previous problems, I encourage you to go and see. So far we solved around 500 problems. Stay tuned for this episode. Let us see the question number 1. The starting metal contains linear chain. It contains 2 alkene and terminal methyl group. You are heating it. They ask you to find the product. The product is a ring closed one, so ring is closed. But the stereochemistry and the ring size is important here. The ring is closed as 5 member or 6 member or 5 member and 4 member. The ring closure is syn fashion or trans fashion. So clearly from the question to product you might understand stereochemistry played the role and special reaction is involved. The answer is A. Let us see how. The starting metal contain alkene. You might think of rearrangement or the alkene rearrangement contain any Fries or sigmatropic rearrangement or in reaction. Let us redraw for the reaction. So if you redraw the 6-member state, you might think of in reaction because it has obvious possibility of hydrogen transfer. So think of the in reaction. So in reaction always established through 6-member transition state. Hydrogen exchange will be there. So hydrogen is exchanged through that. You have the product. But the product stereochemistry is asked here. Any cyclization or any in reaction or any sigmatropic rearrangement occurs through the syn fashion or you can say concerted fashion. Meaning the reaction all are happen at the same plane. So both groups should be in the same plane, either above or below. But the answer they given us both below. So we rewrite it as A. So the product is clearly A there. Both are below the plane. Here you have to learn two important things. One is you have to imagine the reaction in the straight chain. Always if you see the alkene you think of the rearrangement. Here it's a in reaction. Second thing is the cyclization reaction or this kind of rearrangement is a concerted one. So the product will be always syn. Then the question number 2. The starting metal is cyclohexane system which contain amine and alcohol. Both are in the trans fashion. You are using the nitrous acid. They ask you to find the product. The product is simple ketone or the contracted aldehyde or the alkene with alcohol or the epoxide formation. So clearly the reactant to product you might guess the stereochemistry plays the role and it contributing to the reaction. The answer is B. Let us see how. The starting metal you have amine, you have to think of transform. The transform can be on two positions. If you redraw nicely, the stereochemistry can be followed easily. So we redraw to the chair form. There are two possibilities in the chair form. Both can be axial and both can be equatorial. From the stability or thermodynamic point of view, always equatorial position is stable, which is the major form. So we eliminate the axial form. So we proceed the reaction with equatorial form. So both amine and alcohol in equatorial, you are using nitrous acid. Nitrous acid converts NH2 into N2, which is in the plus form. So N2 is a good leaving group. It need little trigger. Always trigger is come from trans group or anti-periplanar group. Here 6th carbon is trans to that one. So 6th carbon assists the nitrogen removal. So 6-2 bond formation will be there. 6-1 bond will break. So the ring contraction occurs there because trans group migrate and help to remove the N2. Then the charge has to be quenched. What really happens is hydrogen removal charge quenched as aldehyde. Here you have to learn two important things. One is stability. Even though we written both different transform, the transform with axial groups are unstable but equatorial groups are stable. We progress from there. Second thing, the N2 elimination. N2 elimination always assisted by the trans group. Here trans group is 6. That's why ring contraction is occurred. Then the question number 3. The starting metal is fused system with hydrogen which is in the syn form. you are having anhydride which is in the cyclic form. You are using LDA in the first step with phenylselenide. Second step you are using LDA with methyl iodide. Then the third step you are using peroxide. They ask you to find the product. The product can be on 4 types, whether the ring is converted into cis or trans, or the alkene formation, and where the alkene is the question. So the alkene formation and ring stereochemistry is important here. By looking at the selenium, you might think of special reaction. Definitely the reaction proceeds to the alkene formation. The answer is A. Let us see how. The starting middle you have ester in the one ring which has 2 active hydrogen which can be removed by LDA. So LDA remove those first carbon, you are attacking with phenylselenium. So the H plus is removed, selenium attack there, you have selenium carbon bond. Then again you are using LDA. LDA again abstract the proton, you are attacking with methyl iodide. So you have methyl attachment. Here the important thing, methyl always attack the less hindered phase. So it attack near the hydrogen. So you attack on the same plane on hydrogen. So it is above, selenium is below. So you have selenium and methyl, both are anti. Both are in different plane. Next step you are using hydrogen peroxide. Hydrogen peroxide always oxidizes the metal. Here selenium is metal, it oxidizes to SeO. Here selenium oxide elimination is possible, which is very important one. Why? Because it involves the elimination of beta hydrogen. Here 2 beta hydrogen is possible. One is near the ring which is 1. Another is on the side chain which is 2. But the ring 1 is trans to it. But the side chain is cis to it. So it removed from there. So the reaction is very much possible in the second hydrogen because the selenium oxide elimination is the syn elimination. So you have alkene in the side chain which is answer A. Here the ring stereochemistry didn't disturb. It given for confusion. Here you have to learn 2 important things. One is selenium attachment. Selenium attachment is possible by any removal of acidic hydrogen. Second thing is selenium oxide elimination, which is very much important because it removal of selenol elimination. It is a syn fashion reaction. Most of the time it defined by stereochemistry. Then the question number 4. The starting metal you have cyclopentane which is reacting with alkene which contain phenyl and nitro group. You are heating it and you are adding sulfuric acid. Here 4 products are given, 4 products are bicyclic system, but position of phenyl and carbonyl is the real question here. NO2 is vanished from the system. So the CO position, pH position and the another alkene formation. So from the nitro group and sulfuric acid you might guess it's a naming reaction and definitely ring fusion is occurred there. The answer is B. Let us see how. The starting metal you have alkene which is dienophile because it attaching with electron withdrawing group. Then you are having diene. So definitely 4 plus 2 cycloaddition is possible. There are the 2 possibilities. Nitrogen is on below or pH is on below. Nitrogen is below due to the steric region. Nitrogen is smaller one. Phenyl is the bigger ring there. So nitro group is on endo form. So you have it as a major. Next step you are using sulfuric acid. NO2 is there. This reaction is called Neff reaction, which is very important reaction. It converted into unassuming ketone or carbonyl there. NO2 converted into carbonyl, it's called Neff reaction. So the answer is clearly B there. Here you have to learn 2 important things. Whenever you are thinking of cycloaddition or Diels-Alder reaction, you might think of the stereochemistry. In normal Diels-Alder reaction, endo product is favored, but which group coming into endo is important. Here NO2 is coming due to the steric reason. Then the Neff reaction. Neff reaction converts NO2 into CO. So it's a functional group conversion reaction. Then the question number 5. The starting metal is cyclohexane which attached with methyl group. In the side chain you have hydrogen attached with SO2AR which is aromatic moiety. Then you are using the base and heating. Here 4 choices are given. 4 choices are, one is cyclopropane formation, another is alkene formation, another is alkene in the different position. The D1 is that within the ring you have the fused form which is one side 5 and one side 3 member ring. So there are the 3 products which is around the leaving group which is NNHSO2AR. From the reactant to product you might think special intermediate is involved and its quenching possibility, whether it's quenched as cyclopropane or alkene. The answer is C. Let us see how. In the starting metal you have hydrogen which contain one active hydrogen, so it can be removed by the base. So base subtract the proton, you have the anion formation. So you have to quench the anion by all possible ways. So what really happens is nitrogen donates the electron and SO2AR is removed. SO2AR can stabilize itself, so good leaving group. Then you have N2 formation. N2 is a very good leaving group. If you heat that one, you got the N2 elimination, you have carbene. Because sudden removal of N2 leads to the carbene there. So carbene is formed. Then the carbene has to be quenched. How it will be quenched? There is only one possibility, CH insertion. It inserts into the carbon hydrogen bond. So obviously the ring is retained, only double bond is formed as new there. So the answer is clearly C. Here you have to learn two important things. This reaction is like Sapphire reaction, but not really. Here hydrogen, the active methylene group, dictate the whole thing till the removal of N2. Then CH insertion. Carbene has to quenched in any way, so it quenched by CH insertion because it is the only possibility. That's all from this episode. I hope it was easy. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.